A very warm welcome to all the attendees today. McGraw-Hill welcomes you all in a discussion with Dr. Abhijit Chakrabarti to share his expertise in the field of basic electrical engineering and methodologies for students and guides to approach courses in this electrical engineering in a better way. Today, our speaker, Dr. Abhijit Chakrabarti, has over 30 years of teaching and research experience in the diverse fields of power system engineering and over 5 years of experience in the industry. He is a published researcher with 132 research papers in peer-reviewed international and national journals. He has authored 18 books in electrical engineering, and he is a recipient of the Pandit Madan Mohan Malviya Award for his research publications. I think we are really looking forward to simplifying some basic approaches to electrical engineering and learning some new techniques from him. Over to you, sir.
Thank you. Thank you very much. I convey my best wishes to you all. And today we will be discussing related to the basic electrical engineering issues which the students at the very beginning they face, as well as my junior colleagues and other colleagues. They also face some problem in making the students understand the basic issues of electrical engineering just at the beginning. The students, they come from the school and this environment is different, that engineering institute, and they start with the new subject, particularly this electrical engineering. They have the background in mathematics, physics, so basically there should not be any problem, but the approach is very important, and because of the approach, sometimes they are not very much feeling comfortable in studying or learning the basic concepts of electrical engineering. So this approach is very important, and today we will discuss about this aspect and how we can make this more interesting to the student, how we can provide them some basic interest, basic knowledge, basic learning tool in this branch of engineering. Now this is a newer branch in electrical engineering. This electrical engineering is a newer branch comparatively to other many branches of engineering, and it started its journey in the commercial sector, in the distribution, transmission, generation sector, right from the 19th century. Now, basically, this branch covers the technology of electricity. So it can be used in power systems, it can be used in electrical machines, it can be used in control systems, it can be used in power electronics. So there are many fields and subfields in electrical engineering which can be easily understandable, from where you can get greater knowledge and you can learn by heart once you have a very good understanding of the basic electrical engineering aspect. It mostly covers at the very beginning the overview of the entire electrical engineering. Now, it basically deals with the apparatus in electrical engineering, the appliances, and the system. So sometimes we call it as a synonymous to knowing about electricity of apparatus and systems. Now, once we go to the very beginning, let us remember the contribution of our pioneers in the field of engineering. Without mentioning their name, any discussion in electrical engineering is useless. It starts with Volta, it starts with Faraday, it starts with Kirchhoff, it starts with Ampere. You know, Professor Faraday, he developed the electromagnetism. And on that basis, today we see electrical machines, we see drives, we see electromagnetic principles, application of the principles. Kirchhoff, he was a German scientist, Kirchhoff, and he developed the different laws that help us in solving numerous circuit. Numerous circuit solution is possible using his development or his creation of the topic. Next, we come to Volta. He was the pioneer in developing the concept of EMF, electromotive force, the voltage, the potential. Ampere. He developed the concept of current, and the unit of current, unit of voltage are named as ampere and volt. Then Oersted. He was a pioneer in developing the concept of magnetic field. How we can use the magnetic field in electrical appliances and apparatus. He developed the concept. Then we can go to Professor Ohm. You all know Ohm's law. And in basic electrical engineering, all linear circuit, all passive circuit, they follow Ohm's law. We come to Edison. He is a pioneer in applying the concept of electricity in developing appliances and modernizing the electrical engineering, which comes to even television level. And Franklin is a pioneer engineer in developing commercial televisions. Tesla, Nikola Tesla, he developed in US at a very early stage of his life the concept of motor, induction motor, AC motors. The induction motor is developed with this concept. Then Franz Watt, he is also important in developing semiconductor devices as well as the some basic concepts in digital electronics. Professor J.C. Bose, he was a pioneer in developing wireless transmission, and there are many more. So their contribution, it comes to the electrical engineering, and the basic electrical engineering, when we start with the application of these concepts to make easy, understandable the concept of entire electrical engineering. Now, the fundamental, if you go to the fundamental of electrical engineering, it is basically, I have told you, just the basic concepts of electrical engineering applied to AC and DC. We talk about the AC supply, we talk about the DC supply. These two supplies are covering almost 90 to 95% application of electrical engineering. The concepts are very important. The concept of electrostatic, the concept of electromagnetism, they all come to basic electrical engineering to explain its application. Then, when we read about the basic electrical engineering, we have to know that in our country, we have some prescribed syllabus in basic electrical engineering. Now, the basic concept of electrical engineering is basically subdivided in two aspects. One relates to pure classical electrical engineering, one relates to electronics engineering, that is basic electronics and basic electronics application. Now, in case of basic electrical engineering, which we are interested today, we talk about its application in various fields, and also earlier when it started the journey, that time there was no difference between electronics and electrical, but with development of knowledge, development of more technology, there are numerous things which we have classified in pure electrical, in pure electronics. So we have basically two branches of electrical engineering in its basic form. One is in electrical, classical electrical part, one is in classical electronics part. Now, while we teach this basic electrical engineering, we see that in the class, all freshers are there. They are having the knowledge in basic mathematics, science, that is the physics and mathematics. Basic electrical engineering is mostly covering the application of physics and mathematics in a particular form that leads to the application of electrical engineering in our daily life. This is basically the concept, or this is basically the objective of the basic electrical engineering. The concept stated in the basic electrical engineering that include full-fledged application of the physical and mathematical concepts, and that includes trigonometry, that includes calculus, that includes algebra. So all these are as far as and when required, we bring them to solve the problems related to basic electrical engineering. Now, the teacher needs to motivate the student. The teacher, when we feel we need to motivate the student, that time we have to talk about its application mostly. Obviously, we need to teach the basic theory. That is very important. Unless and until this theory is very clear to the students, it's very difficult for them to solve the problems, to go for application of the concepts. But it is also equally important that while we go on teaching the theory part, we must in every state, in every step, in every stage, we must see that its application is being taught. Until and unless the application is taught, and some particularly interesting applications, it's very difficult to motivate the students to learn the basic electrical engineering from his or her own interest. Once he or she is motivated, then it's not a difficult job for the student to learn the basic electrical engineering from various books, from numerous resources, from internet, from teachers, and from different other applications. Now, the teacher is to moderate the deliberation with a very clear concept of its application. I have told you that just theory is not sufficient. Its application is very important. Let me give a very simple example at this moment. In our domestic environment, we frequently see in some houses, in some phases, the voltage rises at a very particular moment. In some phases, the voltage drops. Even there are numerous cases where we find that in some particular phase, the voltage is abnormally high, whereas there is no power, no current in other phase. Now, if we formulate a problem, if we devise a problem, if we devise this problem in a fashion of a typical classroom problem, then the students will be motivated to solve, because every time we see this is an electricity fault. Once we know the basic electrical engineering concepts, we can explain how it happens, why does it happen. So this is very important that while we discuss, we must illustrate some daily life problem in attempting the student to get motivated. So this is very important. Now, the teaching learning process, which is now taken as very important in any perspective. In all perspectives, this is very important. If you talk about the quality assessment by the regulators of the engineering institutes and the regulators and the syllabus orientation committees, they all talk about the teaching learning process. In the teaching learning process, it is very much important that we go through the concepts in a very modular form, in a very particular approach. We need to teach the student in such a way so that his knowledge gets developed step by step. Suppose suddenly I start with transformer. It's a very important chapter in basic electrical engineering. So that may not be interesting. We must teach the concept of electromagnetism first, and then we should enter to the arena of transformer teaching. While we teach transformer, we need to train them in the laboratory how some of the applications of transformers, some of the testing of transformers, we can teach them or we can make them understand so that they are able to learn how does a transformer work, how it can be applied, where it can be applied, and how we can get maximum benefit from this electrical device. They all learn in their 11, 12 plus 2 courses the concept of transformer. But that is highly theoretical. Now, concept of electromagnetism applied to transformer, application of the transformer at the at least at the laboratory level, is very much important. And some problems need to be formulated with the application of the transformer in daily life. So they get interested. Even we can attempt to make them understand a very fundamental design type of problem of the transformer. They will learn the transformer design in their machine design course in detail. But to make them interested in designing a transformer, in manufacturing, in fabricating a transformer by their own, for small transformer, a radio transformer, a pulse transformer, a small transformer, they can be motivated how, what is the policy, what is the concept of designing a transformer. So this is very important. So in all the chapters, we should see that the student gets motivated to learn by themselves. In the laboratory also, we need to set up the problem, we need to set up the experiment in such a way so that they learn something from the experiment. It is not that they perform the experiment as the guide tells, as the teacher tells, and accordingly they get some result, so the teacher gets the marks, or appear the viva gets some marks. No, this is not the issue. The objective is to make them learn how the transformer works, how it is applied, and what is the outcome of learning the transformer. Similarly, for each chapter, the learning outcome must be understood for everybody. Now, while we go for that, in modern quality assessment tool of a program, of a course, we keep some eye, we keep some interest on educational objective. Now, for basic electrical engineering, this educational objective is very important. Now, what does it say? It clearly states that the electrical engineering graduate, after completion of the graduating study, he is expected to know, or he is expected that he will be able to do as it is required by the industry, as it is required by the higher education sector. He is to perform there after the complete study. And successfully, the student can apply the fundamental concept of electrical engineering to solve the problems being faced every time in the engineering sector. In the industry, when a student joins after graduation, suddenly the student faces numerous problems of application, and sometimes they get puzzled. So once they are acquainted with the problems to some extent, once they have a clear theoretical background, once they know the application aspect, then it may be easier, much more easier to tackle the problem. It's not possible to ascertain what would be the problem, in which industry the student will go, in which sector he will perform. So that is very difficult to ascertain in the college level. But once the concepts are clear, in whatever sector, in whichever sector the student goes, he or she will find that it is not that much difficult to address the problem. So this is a very important educational objective. It is very important to successfully apply the procedures and steps for diagnosing a problem. It is very important. A few months back, I faced such a problem, and I told my graduate students to tackle the problem, and some of them, with their innovative ideas, they could solve or address the problem. One slip ring motor started as soon as the voltage was given, but the rotor was open. So how did it start? So that was the problem. It was a railway motor, big motor. It was around 400 horsepower motor. So that problem could be solved. How could they solve? Because of their clear knowledge in electrical engineering. And once I assisted them, so once I have given them ideas that this could be the reason, you test it and you find what is the problem, they could solve it. So once the engineer who is a fresher in the industry after graduation faces many problems, if the idea is very clear, if the concept is very clear, then he or she will be able to solve the problem. So this is a very important how to diagnose the problem. So that is very important. Now it is very important to acquire new knowledge in the industry. There are numerous avenues to gain knowledge. The student is to be motivated right from the beginning that once he or she enters the industry, he has a taste to gain knowledge. Then to conduct and the uh, perform the repairs of electrical equipments. It is not every time required the engineer repairs with his or her own hand. There are supervisors, there are mechanics, but he is to or she is to diagnose the problem, tell at what point repair is to be done, which is to be repaired, how is to be repaired, then they can do the repair. So it is very important, this concept is very clear to the student or the fresher engineer. It is very important to identify and analyze as well as to solve the normally defined problems. Say somebody goes to a power station. In the control center, he or she is posted. So he observes at the evening period that the system voltage is slowly going down. It is to be arrested. The decline is to be arrested. So there are prescribed procedures which can be followed by the engineer, control engineer, to arrest the problem. So he or she must know what are the prescribed procedures. He or she must understand what does it say, and accordingly it is to be implemented. Then it is very important to apply the written and oral communication with the superior, with the others, with the colleagues, so that the entire team can work in cohesion and the problems can be solved. Now, once the concept is very clear and the student is graduated, numerous opportunities come. We should not be baffled with the transient market trend of decline as well as uprise. Say 6 to 7 years back, we used to find there is little demand in IT and computer science. Nowadays, we find the demand is very high. Nowadays, we find sometimes the core branch is getting less student. So, people are getting confused, puzzled. Where shall I go? But this is not the permanent case. The core branch is always having the facility to attract people, because whatever industries are there, whatever development a country will have, it is through the core engineering. So the core branches have always the demand for the student, the demand for good engineers. The main problem is that demand is there, supply is there, but there is no bridge. There is enough gap between the two. Sometimes our engineers are not well equipped to deliver whatever the industry wants. So they are not equipped with that. What is the basic reason? The basic reason is two. One is lack in application of the concepts, the deficiency in application of the concepts, and two, the problem in communication skill. So with my long experience, I have found once the student has a better concept, better conceptual background of the courses he or she has gone through, and and workable communication skill. I'm not talking about very high communication skill. Working communication skill, then he or she has got no deficiency anywhere, and it may not be a difficult job to get a good berth in the industry. Core sector demand is always there. There is a base demand. There may not be a surge sometime. Say in 2020-21, there may not be a surge. But you may find a surge in 2022-23. You may find a surge in 2025. So we cannot predict. It's very difficult to predict. And I don't believe there is any acceptable sacrosanct model which can tell us, yes, in 2025, this sector will be having maximum demand, this sector will be having minimum demand. No, we cannot tell it. The market demand can be predicted in this way. There are always ups and downs, but there is a base demand. There is a base demand. Minimum requirement is there. And once this COVID problem is over, we expect there is a surge in economy. There will be more industries to come. There will be foreign investment. So there will be medium and small sector industries that will flourish. And everywhere electrical engineer is required. So it is very important to understand that what is my objective, what is my opportunity. Opportunity is there, but the student is to prepare himself or herself to face the challenge. It is not that somebody will come and call you and give a job. No, it's not that. You have to prove yourself worth for the industry. And the teachers, we need to train them accordingly. They have to go for vocational training. They have to go for internship. They have to learn what a research paper states, what does it mean, how we can apply in industry. They should have industrial visits, and moreover, in the daily class, they should have some industrial problems to solve. Then only they can be motivated to face the challenge of the industry. So this is very important. Now, in our country, the regulator of engineering course is AICTE, All India Council for Technical Education. So they have their prescribed syllabus. If you go to website, you will find there are prescribed syllabuses. Now this syllabus is made with after a lot of brainstorming, and renowned teachers, persons from industry, they joined hand to make the syllabus, to prepare the syllabus. It is not mandatory that you have to follow it, but it is a prescribed syllabus, and since many people, many pioneers have generated it, so it is better that we consult the syllabus and prepare our own syllabus, which should be in line with that one. So this syllabus has covered a broad aspect of basic electrical engineering, and it tried to implant, or it tried to motivate the young students to learn knowledge and to develop the concept once they go through the prescribed syllabus. There are numerous textbooks in electrical engineering, basic electrical engineering, but a good textbook should have a lucid presentation of the theory. It is a must. Lucid presentation. It should be understandable to the student. It should be very much interesting for the supervisor, for the teacher, to ask them, the students, to follow. It should have good theory. It should have lucid derivation. It should have many problems, different type of problems solved. It should have competitive problems solved. It should have MCQs solved, and it should have MCQs, problems, short, medium, long problems given to the student with some minor hints so that they are motivated to solve. Only giving up many solved problems does not solve the problem. You have to also motivate the student to solve them with their own attempt. And for the student, I must tell you, once you go on solving the problems, in the beginning, it may take much time to solve a single problem. But don't get disheartened. Once you try to solve a problem and knock at various doors of concept, you will be able to brush up your mind with concepts. So that clears your concept, that clears your application mind. So even if it takes half an hour to solve a problem at the beginning, let it be. You go on attempting. You will find later that it may be easier for you to solve an unknown gate problem within 5 minutes. It may be easier for you to solve an unknown engineering service examination problem within 3 to 5 minutes. But this background attempt is very important. So once you go through the solved problems, let you go through the solved problems. Try to solve a few at your own. If you are unable, check the solution. And then you start solving the problems which are set in the exercise with some hints or without some hints. So a good textbook should have such things in one volume so that you are able to see it. So the features which I have told you, the features must include competitive examination problems, MCQs. Sometime I have heard that some authors or some people, they don't like MCQs. They always like subjective problems. No, we should not be rigid like that. We should be flexible. There should be MCQs, there should be subjective problems also. Until and unless a student attempts both, the knowledge is not clear. Only subjective problem does not ignite the mind to choose a right answer from many answers. So this judicious mind develops only you go for solving MCQs. In MCQs, you have to choose the rightmost answer from many answers, which may be wrong or which may not be right to the true sense. So it is very important that you solve MCQs also. And not only the MCQs which are set in GATE, should be many MCQs which are newer type. So a good book should have such type of new MCQs. Because in an MCQ that is set in say 2014, it will not be repeated. But the pattern, the concept, once you know the concept, you may find the same concept has been repeated in a different way. So your concept is clear, you can solve any problem on that topic. So it is very important that in your MCQs, you try to solve many problems. Not only the theory problems, also the numerical problems. Intelligent type of problems you must see. Now, AICT prescribed syllabus covers these topics which are shown in the display. The basic concepts, DC circuits, that is application of DC circuit, application of DC, that is analysis of the DC circuit from very basic concept. How you can go for application of DC circuit and how you apply the network theorems. There are many theorems which simplify the application, which simplify the circuit application. So that must be known, that must be clear to you. Then you can solve many circuit problems. Then time domain analysis of the first order passive circuits, RL, RC, and RLC circuit. The time domain analysis is important because in electrical engineering, the performance of the circuit changes with application of potential, with application of the impulse, with application of the source. The response changes because the source itself is time varying. So it is important for time domain analysis. Then you go for AC circuit. Until and unless you have a very clear concept in AC circuit, you can't solve any problem in practical electrical engineering. Three-phase circuit is very important because all commercial circuits are three-phase circuit. So you must know the relationships. You must have clear idea about application of three-phase circuit. Then electromagnetism and magnetic circuit. Once you are very clear about this concept, then your knowledge about the transformer will be very clear. Then you come to the electrical machine part, rotating machine. You have DC motor, you have induction motor, you have synchronous machine. So there are different types of machines, out of which these three are basic machines. So you should have a workable knowledge, you should have a basic concept clear to you on these topics. Then there is power converter. Now there is maybe a question, why power converter is included here? This is very important. Every time we see, starting from the e-rickshaw, starting from the battery operated toto, starting from the battery operated bus, starting from the battery operated vehicle, electric vehicle, now we are always trying to go towards environmental friendly energy application. So these electric drives, they get very importance in application in this field. Now, to control such drives, your knowledge about power converter is very important. It consists of DC to DC control, it consists of DC to AC control, it consists of AC to DC control. So, these controls should be clear to you in the basic concept. You will learn in detail in the power electronics course. But basic concept must be clear to you that how we can use semiconductor devices to have a very good control on such applications. So knowledge in power converter is important at the initial level. Then electrical installations. You may be finding that in many standard courses, there is no mention of the electrical installations we use in our domestic and commercial sector. But this is very important. What is our MCB? What is our wiring cable? What is switch connection? Everything should be known to an engineer. So this has been included by AICTE so that your knowledge about electrical installation, including earthing, which is very important, earthing and grounding, that is known to you. Then basic concept about electrical measuring instrument, ammeters, voltmeters. You know about galvanometers in your class 2. You know very basic concept about ammeters and voltmeters. But there are very indicating meters, very high number of indicating meters, energy meters, recording meters. So you should have some idea about that one, on which principle they operate, how they measure, all these things should be known to you. Then the book should have some lab experiments. Every time we perform lab experiment in a laboratory, but there is no clear guidance about that. Only the lab sheet and the supervisors, they tell the students only know that much. But once there is a guideline from a book with some common concepts, that will be very much important for the student. Now, while we go for application, just I will tell you very few, 2, 3, 4 applications that may ignite the mind of a student. You see a very basic circuit. A lamp is there, a bulb is there, and there is a switch. Supply is there. Now the question is, if we switch on the switch, now the switch is open. If we switch on the switch, whether the lamp will glow or not. Apparently it's a paradoxical situation. Whether the lamp will go or it will not glow, I cannot tell. But if you just apply the mind, you will be able to see. Only the condition that is stated in the problem, that all the resistances PQRS are equal. So that is the lead, that is the clue for the answer. Once these all resistances are equal, it is a balanced bridge circuit, which you will know from electrical engineering, basic electrical engineering. It's a balanced bridge circuit. So in a balanced bridge circuit, the potential at the top and the bottom of the bridge is same. So whether you switch on or switch off S, it does not matter at all. The lamp will continue to glow. So such type of brainstorming can be done by the teacher in the class to motivate the student. We can see another problem. Now here there are two circuits. Question is, in the left hand circuit, one ammeter is there. If we replace the battery and ammeter, whether the ammeter will read the same. The solution is given here. And it has been shown in the solution that yes, the ammeter will read the same current, whether it is in the first figure, that is figure 2, or it is in the third figure, figure 3. Now this is basically the concept of reciprocity theorem. While we teach the reciprocity theorem, if we start with this interesting application, that it will be easier for the student to learn or to know the concept of reciprocity theorem. Similarly, other theorems also, we can start with having solution of very simple, interesting problems which directly shows the application of that theorem. We can go to the next one. This is an inductance. Now the question is a 50 millihenry inductance, 5 ampere current passes through it. The current reverses in the opposite direction in 25 milliseconds. We need to find the average voltage induced in the inductance due to the current reversal. The solution is given. You see that average voltage is calculated. The current is going from say -5 to +5. So the basic concept of Faraday's electromagnetism, that is induced voltage is equal to L di by dt. Di is the change of current. Here the current is changed from -5 to +5. So this change in the time 25 millisecond dt, if we show in a very simple example, it will be very clear to the student how this L di dt concept is applied to the common circuits. So this is a very simple application. And such type of applications can ignite the mind of the student to go for larger application, more complicated applications. Resonance is a very common problem, resonance in AC circuit. You will find many questions in the interview, in the subject examination, in competitive examination from resonance. Now, it has been shown there are two parallel circuits, RL and RC. Now, somebody is telling you, yes, they will be always in resonance irrespective of frequency. At every frequency, they will be at resonance, provided R has a particular value. Yes, that is shown here. With a R, with a particular value, we can show that these two circuits will be always in resonance. So this is a very interesting application of resonance. Normally we know that resonance occurs at a particular frequency between R and RC circuit. But there are exceptions. For a particular value of R, if we can relate these constants, we can find resonance is possible at all the frequencies. So this ignites the mind of the student to think about in a greater way, what is resonance, what is this application, how we can apply it. So this is also an interesting problem. You can go for electromagnetism application in the transformer. Say we have to design a transformer with space constraint, but we want the same performance. Say in the aircraft, space is small. We want the same performance of the transformer as that is in the ground. So there we have shown here that how increase of frequency can result in giving the same performance like the transformer on the plane. So such type of such type of conceptual approach is very important for the student to know that yes, its application is everywhere. In electromechanics, in induction motor, there is a problem, simple problem shown here, where we have found the efficiency by determining the losses. Here, the student is, the concept of the student is made clear about stator loss, about the rotor loss, about the rotor input, about the rotor output. So how the induction motor calculations, performance analysis can be done, such type of simple problems can illustrate. The supervisor, the teacher, must start with interesting simple problem to make the student interested in this topic. Once the interest is generated, then it is not at all a problem to go for tougher problems to complex problems. But it is important to make the concept clear by application of such type of simple motivating problems. Now in power converters also, you can have simple problems to show how you can get a desired voltage DC from a AC supply. How we can get a DC desired voltage from another level of voltage of DC through chopper. How can we voltage boosted up? How can it be reduced? How can I have voltage from AC source to DC, from DC source to AC? That is, inversion is possible. So such type of basic concepts should be implanted in the mind of the young student. We should also learn, I have told you earlier, that we should learn about the application of wiring and LT circuits. It is very important. There are people who have got very good bookish knowledge, but even they may not be competent enough to work in the practical sector, in the maintenance, in the repair of LT supply, in the commercial and household sector. That time they need to take the help of supervisor, they need to take help of the mechanic. No, we don't want it. We want an engineer having good theoretical knowledge as well as practical application concepts must be clear. He should be able to diagnose the problem, he should be able to address the problem, he should be able to throw the solution of the problem. So that is not known until and unless they have preliminary ideas about these LT circuits, wiring, appliances, and equipments used in low tension circuits. So that is very important. And then application of measuring instruments. Application of measuring instrument is always important. Even nowadays, even digital instruments have come, still they are very important. And many utilities, they retain the analog type of instruments for better understanding. So the knowledge of measuring instrument is very important, like energy meter, watt meter, ammeter, different type of testing instruments must be known to you. While you will be working in the practical field, say you are in the distribution sector, you find there is a cable fault. How do you know under the ground where is the fault? So there you have to find the fault using the cable testing apparatus, cable fault detection apparatus. So you must know its operation, you must know its principle. Otherwise, you will not be able to interpret the reading. So that basic idea must be there. So what I want to tell you in nutshell, that until and unless you have a very clear concept in basic electrical engineering application, and we the teachers, we ignite the mind of the student, we trigger the mind of the student with application of basic electrical engineering in daily life to see the problem, to diagnose the problem, to address the problem in while he is a or she is a graduate, then the other topics, other subjects is of no use to them. And it is very important that you should have proper book, good book in basic electrical engineering. I am an author. I know how to present the book in a proper form so that the book gives almost everything to a student, and we go for revision continuously so that new things, new concepts, new applications can be incorporated in the book. So reading a book is very important, and I must tell to my junior students, to my students, to my beloved students, that it is not very much advisable to only depend on internet to gather the knowledge. You should have a habit to read books. Then your knowledge is full-fledged. In internet, you can get a superficial knowledge. Or even if you want to get a depth of knowledge in a particular topic, you may get it. But electrical engineering is not that. Electrical engineering makes you competent in its all the branches with your interest generating so that you can solve many problems at different sectors. So reading of book is very essential, and I advise you to go for reading of books, solution of MCQs, solution of problems, solution of subjective type of problems, objective type of problems, and even if possible, try to generate a few problems of your own and then give it solution. So that will be very much interesting, that will be very much motivating, and that will be very much appreciable. So I hope that whatever I have told you is my fault from my experience. So you will consider, and in case you have any suggestion or query or clarification, I am here for a few more minutes. You can ask me. Thank you.
Thank you so much, sir, for this wonderful talk. I think everybody has been enjoying it so far, and they have posted some questions for you as well, which I would like to take one by one. So, Mr. Virat Bhame is an attendee, sir. He asks, can you please recommend some books for basics of electrical engineering which you like?
In our country, as well as globally, the books published by McGraw-Hill are very authentic books. So I would blindly recommend these books, and there are other books also. If somebody is interested, go to the library of the institute and find many books. But to possess a book, to have a very clear idea on the subject, I will certainly recommend the books published by McGraw-Hill, because these books are very authentic and they publish the books of renowned authors only who are very experienced in offering the subject throughout their lifetime.
Thank you so much, sir. We have one more from Mr. Sanjay Bhadra. He asks, so in the teaching and learning process, how do you think we can bring the flair of industrial application while teaching theory, especially with first year students?
While we go for the subject-wise teaching in basic electrical engineering, for each chapter, we can have, the teacher can have predetermined few problems related to industry, just which I have told at the very beginning that in some phases, sometime in the evening, voltage is low. In some phases, voltage is high. Why does it happen? This question can be thrown to the students. Let them read and answer to me. It's a home assignment type of problem, and that is a very practical problem that can be given to them. It can be given to them that sometimes we face power failures. Why? What is the basic reason of power failure? Sometimes we face problem with the transformer operation. Transformer is not giving the rated voltage at its output. We can devise a problem with some practical data so that I show that transformer is defective. What could be the reason or what is the remedy? The student can think and give a home assignment problem to us, answer. Like that, in each chapter, in say network theorem, say Thevenin's theorem, we can give a practical network to them and to tell them solve this network to give the analysis of the network and to see its performance. So they are bound to apply the network theorems, and until and unless they have got very clear idea about it, they can't apply. So they will read and apply it. So in each chapter, we can devise a few problems prior to starting of the course, some few applications, and then we can show it in the class. Next.
Sounds good, sir. We have one from Mr. Arijit Ganguly. He asks, nowadays, as per AICTE syllabus, concept of heavy machineries such as synchronous machines and its fundamental level is present in basic electrical engineering. How this can be presented in front of fresher students in a generalized way?
Now, while they go for synchronous machine at the end of their syllabus, it is almost at the end of their syllabus. They have already knowledge about the DC machine and induction machine. Now, once they have a knowledge in induction machine, in the very beginning, you see in the syllabus it is written concept of three-phase rotating field. So once this concept is clear to them, then it will not be at all difficult to apply this concept to make them understand the basic concept of synchronous machine. So once the concept of rotating field in the machine is clear to the students, it will be easier for them to know what is the concept of synchronous machine. And in synchronous machine, the syllabus in the basic electrical is oriented in such a way so that it is only the fundamental concept of a synchronous generator and a very small application of the motor. So it is not that much difficult for a supervisor as well as for a student to interact on the basis of their knowledge to learn on synchronous machine. It will not be difficult. We have taught it a number of times for many years, and we have seen that once the concept of DC machine and induction machine is clear to them, they are mostly accustomed, or they are not facing much difficulty in understanding the concept of synchronous machine. Next.
Okay, sir. We have one from Dr. Catherine TJ. She asks, can we define PEOs for a course that is BEE as it is shown in the presentation?
Which one?
PEOs for a course in Basics of Electrical Engineering. Can we define some PEOs for a course in Basics of Electrical Engineering as shown in your presentation?
Let me go back to slide. Which slide?
Yeah.
Earlier one. Is it this one? No, I didn't understand the question very clearly. Which slide madam wants to refer?
That's okay, sir. So we'll request Dr. Catherine if she can rephrase the question for sir. Okay,
Is it
we'll
this
move on
one?
to the next one. So we'll ask her to confirm once. I've just requested
Okay.
her to rephrase the question if she's still with us. We'll move on to the next one. Meanwhile, we have one from Dr. Avidi Ramarao. He asks if you can please differentiate between voltage and current source.
Differentiate.
Yes,
He does you
difference
want to.
between voltage source and current source.
It is given in each of the books, all books. The voltage source is basically a source that generates an EMF and the load current, and this EMF is governed. So for a practical voltage source, this EMF is very much dependent on the load current. And once we go on changing the load current, the voltage profile is of the drooping characteristic. Say a battery is a typical example of a voltage source. In case of current source, if you take a practical example, a rectifier is a very good current source. In case of a rectifier, you can change the current. You can change the current. But once you go for a very low current, that time the rectifier does not operate. The rectifier does not have any voltage across it, but it generates the current which passes through the circuit, and the circuit has itself the voltage across it. So rectifier is a very good example of a current source. And in theory, the current source, in case of theory, the internal resistance or impedance is in parallel with the source. And in case of voltage source, the internal impedance or resistance is in series with the voltage source. So it is given in most of the books, particularly the basic electrical as well as circuits. And while we teach the students, that time we talk about its application through some numerical problems. Next.
Yes, sir. So we are about time, so we'll just take this last question from Mr. Vikas Paneet. They ask, in basic electrical engineering, is it important to solve questions or read theory?
Or,
Read
yes, is it
theory.
now in case of basic electrical engineering for the students, it is very important once the theory is learned, it is to be applied. So application is very important. And while application is done, it is to numerous applications related to subjective as well as objective problems. So until and unless the theory learned is applied, the student knowledge is not full-fledged and he or she will not be able to apply it in industry. Industry wants application. Industry does not want whether the student can remember differential equation, partial derivative, but they want that the concept of design, the concept of partial derivative, everything, mathematical and physical concept should be applied to make a production, to go for a good maintenance, to generate proper outcome. So you, in the background of theory, you must be having the concept of application. Next.
I think that's all, sir.
Okay, fine.
We have more questions, but that I can, for the survey that I can answer. Let's have one parting note from you, sir, and then maybe we can say a thank you note to all the attendees.
Now, if we go for now for this year particularly, all the courses, all the sessions are delayed. So this year, teaching of electrical engineering, basic electrical will be very difficult for us because we will not get enough time. We may not get the students to interact face to face. Online teaching is there, but face to face interaction has some other practical value. So this year electrical engineering, basic electrical teaching is very difficult. So I would suggest the students as well as the teachers to go through more books. Book is very much essential in this year. And once we have a book, we have one or two books in our hand. So whatever we see from online, whatever we learn from online, that time we can we can brush up our mind, we can brush up our knowledge by consulting the books. And in case of further doubt, we can ask the teacher, the student can ask the teacher in the next online session to clarify. So this year, since the time will be very short and everybody is panicked of this pandemic, so this year the use of book is very important, and everybody should have a proper book so that we can go through it and we can clarify. Normally, what is the norm? We can ask 2 times, 3 times, 4 times the student ask us. Beyond the office hours, the student come to us. Beyond the class hours, the students come to us to get the things clarified. But now it is not possible. We have a particular slot, online slot, and only that time we can deliver whatever we want to deliver. And I don't know how much the student is grasping, how much he is understanding. So it is very difficult to interact in this session. So that is the reason, if the book is there, the student will be able to pinpoint what is exactly his or her requirement, and that can be asked in the next session. So this year, my suggestion that we should have more books from the library, from the shop, from the market. The students should have a book, at least 1 or 2 books, so that the things can be clarified. Okay.
Thank you so much, sir. Yes, sir. Thank you so much for this very lovely session, sir. And we
Thank you.
also thank all the attendees for joining us today and this discussion with Dr. Abhijit Chakrabarti. The session recording, PPT, and certificates will be shared to you on your registered email IDs within the next 7 to 15 days. In case you do not receive it, please write to us at support.india@mheducation.com. Sir's book on basic electrical engineering is also there on your screens in the presentation window. You will be able to scan the QR code directly to the Amazon link of the book. If you, in case you want to purchase, please do scan it, or you search with the ISBN that is also given on your screens. Thank you everyone for joining us. Thank you so much, sir, for the lovely session, and we'll see
Thank
you
you.
soon. Stay tuned.
Thank you. Thank you. Thank you all.